All right, ready? So accuracy is defined as how close the measured value is to the true value. That's it. Okay. It's zero or nothing. Okay, got to be honest. An object is weighed on the balance, and it's determined to weigh this. So this is the actual weight. The precision would be 0.01. This is the precision, not the uncertainty that it's asking for. So D is the right answer there. This test will actually have multiple choice, so this is good practice. The wingspan of a female red-tailed hawk is 130 centimeters. What's the precision and uncertainty of this measurement? So you would quickly just say that precision is 1 centimeter, uncertainty is plus or minus 0.5 centimeters, right? So we 130 plus or minus this. Oh, sorry. What is the precision and the uncertainty? So it's precision and uncertainty right here. It's 1 centimeter plus or minus 0.5 centimeters. So it's this one right here. That's the best one, right? So if you don't, the other ones don't apply, so you got to go with that one. Jeanette measured the length of a piece of copper pipe. There's a true value. Tape measured is marked in 0.1 centimeter increments. That's your precision right there. It's the most precise she can record. So technically what this is saying that this measurement device can get as close as this value right here. Right? So remember when I had the voltmeter and I kept changing the decimals, right? This is still there, but you're kind of rounding. So 17.7 is good, would be the closest you can get with that precision. Okay, so this is it. C. A relay team. So this one, I wonder how you did it, but if I look at all of these measurements, they all have the same precision, correct? Okay, they all have a precision of 1 second. That means that they all have an uncertainty of 0.5 of a second. Okay. So what I will do is I will add these all up, right? So you go, if you add up all the minutes, you get 76 minutes and 13 seconds. Which I know you're probably saying, Mr. Dirksen, 76 is over 1 hour. If you caught that, if you went 1 hour and 16 minutes, that's fine. But we can keep it like this because it's just keeping track of the total time of the race. So this would be adding that all up, and then plus or minus, I just went 0.5 times 4, right? Which is 2 seconds. Y times 4, well, you're adding 4 values up, right? So if you go 0.5, because they all have the same uncertainty, you just go times 4, so that's plus or minus 2 seconds. And I saw some other ones, just let me take care of that if you're not sure how you did. There's a big chance that you got it right doing it your way. So you got the whole, you turned everything into seconds. Right, because your precision uncertainty would still be the same. Yeah, I would accept. What is your second answer? You just kept everything seconds right till the end? Yeah. So what are we talking there? Okay, you convert, so this is seconds. Okay, so that'd be this plus or minus 2 seconds if you turned the whole thing into seconds. And then you converted it and you got 76. Yeah, that's fine. I'm fine with that. We haven't done one of these before, so whatever you did, if you added it all up, and I'm most interested in this, add it piece here anyways. So I would give you, what is this out of 3, right? I would give you 1 mark for figuring out the uncertainty of each. I would give you 1 mark for total time and 1 mark for the total uncertainty. So if the plus or minus 2 seconds is there, I would give you 2 out of 3 because you figured out 1 uncertainty and you combined them, right? And then 1 mark for either 76 minutes and 13 seconds, or if you turned everything into seconds, that's fine. We're going to go with it. We'll go with the flow, right? A doctor measures a dose of 2 milliliters for a child. What is the precision uncertainty of this measurement? The precision is 0.01 of a milliliter, and the uncertainty is half of that. It's that many of a milliliter. Okay, so 1 for each. Which one is more precise in this scenario? They all have the same unit, so you pick the one with the most decimals, okay? That's the most precise in that particular case. So this page, if you add it all up, is actually 10, right? So 7 marks for the multiple choice. Wait a minute. 10 doesn't make sense because, hold on. 1, 2, 3, 4, 5 for the multiple choice, plus 5. Yeah, we're good. I just wanted to check. 10 marks. Yeah. Sorry? Which answer? Oh, sorry. 2 and 1 would be AD. A for question 1, D for question 2. 10 marks for this page, okay? So put a mark down at the bottom. Question, Amol? Backside, that's the length of the black bar, including the uncertainty. So you have a choice. It's centimeters up here. If centimeters is split up, it's millimeters, right? At the bottom, just so you know. I think you knew that. But so you have a choice. You can say 62 millimeters plus or minus 0.5 of a millimeter. Or you could have said 6.2 centimeters plus or minus 0.05 of a centimeter. And if you really want to give me a hard time, this is technically also okay to have this in centimeters, this in millimeters, as long as you state the different units. But I prefer you keeping it the same, like, right? Because if you're reading this, then my precision is 1 millimeter, and the uncertainty is half of that, right? Are we good or what? Feel like some of you are not so sure about that. But yeah, just measure it and go. I am tempted to bring a bunch of pieces of wood or whatever, or random elements, and you actually having to use a tape measure to measure in inches and fractions of inch. I think you should graduate and know how to kind of find your way around. Well, that's just it. Like, and you know why? Because we don't like, teachers find out pretty quickly that students do not like fractions, and then they just kind of stay away from fractions, right? We should just be like, you know what? Tape measure, the smallest increment is usually 16ths, right? Or 8ths, whatever. So, okay. Question 9. So you might wonder what's this worth? I would say 2 marks if you did both of them correctly. Is your hand up, Griselle, or no? No, okay. Just making sure. Question 9. Which of the following describes the concept of tolerance in measurement? The length of the gutter must be a minimum of 12 feet. Not quite. A drilled hole must be big enough to fit the dowel, but small enough that the dowel does not fall out. That right there, if you ever hear something like that, has to be big enough, but can't be too small, something like that, where you get like an upper and a lower limit, that is your go-to. The average would not be it. The combined weight, right, has a higher uncertainty than if they were all together. That's also not true for tolerance. Okay. The nominal value is the target value, C. 1 mark for that. Which of the following is another way of expressing this? What I would do here is quickly just say this is max, this is min. You should recognize this by the format, and then you just go tolerance and nominal. You don't even need to fill in the first two. Tolerance, you just subtract these, right? And you get 0.01, right? That's your tolerance there. And do you know what this means? The two markings? Inches. 1 is feet, 2 is inches. Okay. And then the nominal, you'd have to find halfway between. Okay. So nominal would be 7. What did I find here? Hold on. 0.76. And I'm just gonna go like this. I added these and divided it by 2 and got that. So you have your inventory here. You know that that's the max, that's the min. Tolerance, I subtracted the 2, and nominal. So which one of these would be an acceptable? This one wouldn't work because this is not necessarily right. Okay. This one, definitely not it. It's just a value. This is not anywhere, right? So this is not it. So actually all you have left is this. So by elimination, this is it. So you have your min. You can't go any lower, but you can go higher, right? So this is the only one that wins in this scenario. Yeah. Oh. Hey, whatever techniques you use for that's some detective work right there.
One of them in the original font and change the rest of them. Like, if you were gonna do that, change all of them. It's like it being the same color. Exactly. Wasn't
Okay.
just copy and paste?
No, there's a software that generates this, but a lot of these are like if I left it as is, it wouldn't make any sense in my opinion. So I just did that myself. Okay. Well, good for you. Max, the thing is on the test, it's not going to be like that. So don't count on it. Don't give away your secret. Okay. We're not done yet. We got to get our max and our min and all that. So the max here is 64.95 because I go 64.5. Half of this is 0.45, right? So you can just rewrite it like this. So this plus that gives you this. This minus that gives you 64.05. Tolerance, you subtract or you just grab it straight from there. All in centimeters. And the nominal is just 64.5 centimeters. So here it is. If you want it stated like this, you go 64.95 and 64.05. If you have this, you get a mark. Okay. Minimum, I'm going to grab that. Minus 0 plus the tolerance 0.9 centimeters. You get a mark for that. The max 64.95 plus 0 minus 0.9 centimeters, you get a mark for that. So this technically is not worth marks, but it could help you if you get anything wrong. If you based it on these numbers, I would still give you some partial marks here. Okay. So this backside is 3, 4, 5, 6, 7, 8 because the top is worth 2 marks. So 8 marks for the backside. 8 and 10, that's 18, right? So make sure your name and last name is at the top here, and you tally it, pass it forward,